All right, well this is part 2 in our numbers and science videos, so we're just going to pick up where we left off in that first video. It's the same PowerPoint and I hope you have it printed out so you're taking notes as we go along. Again, we are looking at measurements, how we use our measurements in calculations, and how we should report our answer to the correct number of sig figs. Again, the least precise measurement is what's going to be limiting the certainty of our calculated quantity. And that's going to determine how many sig figs we report in our answer. Remember, calculators aren't smart enough to know about significant digits. They're going to give you a lot of numbers, and a lot of them we don't want in our answer. Well, there are only 2 rules using sig figs in calculations, and the first one is the multiplication and division rule. So if you're multiplying or dividing numbers, you need to count the number of significant figures that are in what you are multiplying or dividing. The last video, we practiced counting sig figs. Well, our final answer that we report can have no more sig figs than the number with the least amount of sig figs. Let's see what that means. Here we're going to calculate the area of something in which we've made some measurements. So we measured 6.221 centimeters. That has 4 sig figs, so maybe draw an arrow and say 4 sig figs. And 5.2 centimeters. How many sig figs is in that number? Did you say 2? Good. Well, when you put these numbers into your calculator, you come up with 32.3492 centimeters squared. A centimeter times a centimeter is centimeters squared. That's a lot more numbers than we had in either one of our measurements. So not all of them are significant. Again, we had 4 and 2. This is our least precise measurement, and it's going to limit the number of sig figs that we can report in our answer. So, since this has 2 sig figs, our answer needs to be reported in 2 significant digits. So we would report this answer as 32 centimeters squared. These numbers don't count. Let's calculate the density. Well, we had a very precise balance, giving us a mass of 14.579 grams. How many sig figs in that number? Write it down. Did you write down a 5? Good. We measured our volume, and it was 20.2 milliliters. Write down how many sig figs are in 20.2 milliliters. Did you say 3? Good. So to calculate our density, it's mass over volume. So 14.579 grams divided by 20.2 milliliters. And here is what my calculator gave me as an answer. 0.7217327 grams per milliliter. Whew, that's a lot of digits. This 0 is just holding our decimal in place. Well, we had 5 sig figs here. This value only had 3. We need to report our answer to how many significant digits? 3, right. Our least precise measurement had 3 sig figs, and so that's how we're going to report our answer. So we're going to report it as 0.72, there's a 1. We want this thousandths place, but the number after it is 5 or greater. It's greater than 5. It's a 7. We're going to round that 1 up to a 2. So, reported to the correct number of sig figs, our answer would be, and let's get this written down, 0.722 grams per milliliter. Again, our answer went to 3 sig figs because our least precise measurement was 3 significant digits. Well, that's the multiplication and division rule, where we count our number of sig figs. Addition and subtraction is slightly different. The result has the same number of decimal places, notice it's in red, as the measurement with the fewest decimal places. And we're going to round to the last decimal place of the least precise number. What does that look like? Well, we had a mass of an empty beaker of 112.9 grams. Mass of water was 65.43 grams. The mass of salt was 9.007 grams. We added some sugar. It was 0.6122. How many decimal places are there in this value? Just one. How many decimal places here? 2. We're counting decimal places, not sig figs in this case. How many decimal places in 9.007? There are 3. And how many decimal places here in 0.6122? There are 4. All right, when we add these all up, we come up with 187.9492 grams. Wow, we need to write our answer to the correct number of sig figs. Again, we are looking at decimal places. This one had 1 decimal place. It's our least precise measurement. This one had 2, 3. This is the most precise with 4 decimal places. Well, you guessed it. This value is going to limit the number of decimal places that we can report in our answer. And so we can only report to the tenths place. So we're going to need to cut it off after this 9. Our correct answer in sig figs would be 187.9. We were adding, and so we were counting decimal places. So as a summary, when we're using measurements and we're calculating with the measurements, we want to make sure we report our answer to the correct number of significant figures. The multiplication and division rule, count sig figs. The addition and subtraction rule, count decimal places. It's really not too hard, so try not to get too bogged down by significant digits. Just wanted to say a brief word about rounding. You always look at the first digit that's not significant. If it is less than 5, our last sig fig is going to remain the same. So if we wanted to round this number, 7.28479, to 3 significant digits, 7.28, so that's our 3 digits, go 1 beyond that, it's a 4, so we're not going to round the 8. So our answer would be reported as 7.28. If the number after our last significant digit is a 5 or greater, then our last sig fig is going to be increased by 1. If we wanted to round this number to 3 sig figs, so it's 4.76, so that's our last significant digit. Oh, but the next digit was a 5. We would round that 6 up to a 7. So this number rounded to 3 sig figs would be 4.77. And then just a word about exact numbers. Exact numbers, remember at the beginning of the last video we talked about counting numbers or definitions. They were exact numbers. We say they have an infinite number of significant figures, and that's not going to limit any of our answers significant figures in calculations. We're going to have a lot of practice with this in our next class, so I hope you've enjoyed the video. I hope you've been able to take notes on the PowerPoint. That would be the easiest way to do it. And now we're going to use everything we've learned in this video in our next class. See you then.